Alrighty, in today's lecture, we're going to be talking about 6.3, locating real zeros of polynomial functions. All right, so the main things here is the rational zero theorem. And basically what this means is these are just potential zeros, but they're not the actual zeros. The formula is written as like P divided by Q, but it's really the factors of the constant divided by the factors of the leading coefficient. And again, this just gives us potential zeros that may or may not work. Using synthetic division, we can quickly plug it in and figure out, does this give me a zero as the remainder? If it does, then that would be one of the solutions. And then we would have a smaller polynomial function. So a lot of times, maybe you're dealing with a cubic. If we could just get it to a quadratic, we could solve it using factoring techniques, the quadratic formula, completing the square, whatever technique you like the best, but it's getting it to that stage. So this is one of the ways that we could do it. And then in 6.3, a couple of things to disregard while you're going through the chapter. We will not be teaching Descartes' rule of signs. I teach that in the pre-cal course if you take that next. And then we won't be talking about the upper and lower bounds of zeros. Those two things just kind of help us determine how many positive and negatives we might have, which kind of limit our potential zeros we have. And then a lower and upper bound, depending on what kind of answer we get, can tell us if there's a value less than it or greater than it. And then again, it just shrinks the amount of potential zeros you could be looking at, because it could be just 6 or 8 different type of zeros, or it could be like 60 to 80 type of zeros, depending on how big your numbers are. But we will not be working on that. So don't got to stress about that at all. And then from there, the next big thing in this chapter is the intermediate value theorem. And I know some of these theorems might just seem intimidating or anything because they're theorems and not many students like that. But the intermediate value theorem is what I like to call the first common sense theorem in calculus. And it basically just states that if you have a function a, well, let's talk about this. Let's say you have an interval a to b in a continuous function. Continuous meaning you never have to pick up your pencil, which is very important. But basically just states if f of a is greater than 0 and f of b is less than 0, or f of a is less than 0 and f of b is greater than 0, either one, if this happens, then that means at some point between these two values, there has to be, so therefore, if you've never seen this is therefore, there is a C such that, a lot of people just use ST. So there is a C such that f of C equals 0. And basically what that is stating is that if you plug in one endpoint and then you plug in the other endpoint and one's positive and one's negative, and it's a continuous function, so you never picked up your pencil, at some point the answer had to be 0. So we're stating that at that some point, let's call it C, f of c then would have to equal 0. And that's pretty much the intermediate theorem. Again, basically, again, let's say you have a value here and a value here, right? And it's a continuous function. It doesn't matter what it looks like, but at some point it has to go there, right? So that means at some point it had to cross. A different way to look at it is it might do something like this. It might cross a whole bunch of times, but at some point it at least crosses once, right? And so that's the idea there, is that at some point the function, again, depending on how it got there, cross the x-axis at once. So that's why I always say in calculus, when I teach that course, at some point, this is the common sense one, where if it's a positive negative, at some point it had to be 0. And that's pretty much it in 6.3. So let's go ahead and practice. So I'm going to be on page 409. So number 1, we're going to list all the potential rational zeros of the following polynomial. Then we're going to use the polynomial division and the quadratic formula, if necessary, to identify the actual zeros. So basically, we're going to find the potential zeros, and then we're going to find all the actual zeros. So we have p divided by q, which again is this going to be the factors. Oh, let me just go ahead and write out the question before I get ahead of myself. So this is going to be f of x equals 3x cubed plus 5x squared minus 26x plus 8. So what I'm going to do, again, do p divided by q. I'm going to find all the factors of my constant. So that's all my factors of 8. So that's going to be 1, 2, 4, and then 8. So those are all my factors of 8. And then do all my factors of my leading coefficient. So that's going to be the 3. So that's going to be 1 and 3. And then there's a plus or minus to this. So this is how you work this out. Take all of these numbers and divide it by this one. Then take all these numbers and divide by this one. So 1 divided by 1, the plus or minus all of these answers. So 1 divided by 1 is 1. 2 divided by 1 is 2. 4 divided by 1 is 4. 8 divided by 1 is 8. 1 divided by 3 is 1/3. 2 divided by 3 is 2/3. 4 divided by 3 is 4/3. And 8 divided by 3 is 8/3. If you would have got one of the answers where it's simplified to one of these, you don't have to worry about repeating. And again, I'm not going to make you write plus or minus for each one of them. If you just put the plus or minus on the outside, then I know you have 1, 2, 3, 4, 5, 6, 7, 8, 16 different potential zeros here. And again, not all of them are going to be the answer, or some of them might be. They might all be there. But these are just where you start. Really and truly, when it comes to it, you just kind of have to look at it and go, where do you want to start? So I'm going to be honest with you. I like positive numbers, but I will play with negatives too if I have to. But what I'll do is I'll just plug in 1, and then I'll plug it in using synthetic division. Again, the goal is to quickly get the factor. So this can be time consuming, but I honestly think the math is relatively pretty quick. So here is my synthetic division. So 1 times 1 is 1. 5 plus 1 is 6. 1 times 6 is 6. Negative 26 plus 6 is negative 20. 1 times negative 20 is negative 20. And 8 plus negative 20 is negative 12. Now the goal is you're just trying to find something that gives you 0. So that one did not work. So then you can try negative 1 if you want. However you want to work it out. And again, it's going to be the exact same numbers. So negative 1 times 3 is negative 3. 5 plus negative 3 is 2. Negative 1 times 2 is negative 2. Negative 26 plus negative 2 is negative 28. Negative 1 times negative 28 is 28. And then 36. So therefore, that one didn't work. So let me try 2. And again, I'm just going to write all the same stuff. That gives me 6, 11, 22, negative 4, negative 8, 0. So that means that 2 is a winner. And that means that this right here ends up being 3x squared plus 11x minus 4. Now that I have this in a quadratic, I can then do maybe a factoring technique. So I need to multiply to a times c, which is negative 12, and add to my b, which is 11. And let's see, 1 and 12, and then the negative. So that right there will work. So then I get x minus 1, x plus 12, and then I'm going to divide by my a. So this right here, I will actually say, since you're looking for the zeros, you can actually keep it like this because this right here will turn into a 4. You're going to have to set this equal to 0 to find the rest of them. So if I take x minus 1/3 and I set that equal to 0, that would mean that x equals 1/3. If you move the 3, you would have to add the 1 and divide the 3 and get to the same concept. Remember, my goal for you is to do math correctly and then do it quickly as well, preferably without a calculator, but that's not kind of where we're at. Anyways, we have x equals -4 when you subtract. So those are your 3 answers. So those are your potential zeros. So potential. And then your actual zeros is going to be x equals, let's see, -4, 1/3, and 2. So again, I did -1 and 2, but you could have chose -4 or 1/3 if you wanted to, and it would have given you 0. You would have factored and got the other 2 results as well. So that's pretty much the process and pretty much what you're doing throughout the rest of this problem. All right, so look at number 2. We have g of x equals -2x cubed plus 11x squared plus x minus 30. Potential zeros. Just pay attention to the numbers. Don't focus on the signs because they all have to be plus or minus. I'm going to do all my factors of 30. So that's going to be 1, 2, 3, 4, 5, and then 6. So 5 times 6. And then from there, when you get to this point, you can just go, all right, 3 times 10, 2 times 15, and then 1 times 30. I'm going to worry about all the in between because the numbers would have appeared over here. And then on the bottom, 1 and 2. So your potential zeros are going to be 1, 2, 3, 5, 6, 10, 15, 30, 1/2. 2 divided by 2 is 1, which I've already written. 3 halves, 5 halves. 6 divided by 2 is 3, which I've already written. 10 divided by 2 is 5, which I've already written. 2 to 15ths, so 15 halves. And then 30 divided by 2 is 15, which I've already written. So here's all your potential zeros. All right, then from there, we just choose one. So I'm going to start with 1. And this is, again, x cubed would be -2, x squared would be 11, x would be 1. My constant's -30. So then when I work it out, I get -2, 9, 9, 10, 10, -20. Did not work out. So I'm going to try 2 next. So that's going to be -2, 11, 1, -30. Gives me -4, 7, 14, 15. Ah, ha, 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 sweet. 30, and then that gives me 0. So nice when you do it like on the first or second try. All right, and so then from there, that becomes -2x squared plus 7x plus 15. So again, doing the t-chart method here, multiply to -2 times 15, which is -30. And technically, I'm going to pause here. Technically, this whole thing is set equal to 0 because that's what you're trying to find is the zeros. I don't like the leading term of being a negative, so I'm actually going to multiply everything by -1. It just makes the math better. So now I get, so I still get -30, and I'm still going to add up to -7 versus +7. Let's see, get 2 and 15, 5 and 6, 3 and 10. There it is. So that'd be -10. So then I get x plus 3, x minus 10, divide by 2. So again, I'm going to take x plus 3 halves equals 0. and I'm going to take x minus 5 equals 0. So this would be x equals negative 3 halves and x equals 5. So my actual zeros are going to be x equals negative 3 halves, 1. Oh, no, I have not 1. 2, comma 5. And there you go. So you'll have to find your potentials and your actuals. I want to give you plenty of examples. So let's look at number 3. Number 3 is P of x equals x to the fourth minus 5x cubed plus 10x squared minus 20x plus 24. Again, potential is going to be the factors of 24. So it's going to be 1, 2, 3, 4, 5. It'll be 4 times 6. That gives you the 24. And then that, for when I get to that point, I can then go, all right, well, 3 times 8, 2 times 12, 1 times 24. And then just 1. So that makes it a little bit easier. So this is 1, 2, 3, 4, 6, 8, 12, 24. So then we just try some numbers. So again, I'm going to start off with what I've been doing. So x to the fourth is 1, x cubed is negative 5, x squared is 10, x is negative 20, constant is 24. So then I'm going to go down the list. So 1, 1, negative 4, negative 4, 6, 6, negative 14, negative 14. That would give me 10, which is not 0. So then I try 2. So x to the fourth, 1, x cubed, negative 5. X squared is 10, x is negative 20, my constant's 24. 2, negative 3, negative 6, 4, 8, negative 12, negative 24 is 0. Now, the issue with this one is this is x cubed. So technically I have x cubed minus 3x squared plus 4x minus 12. I still don't know how to factor this. Well, I say that. Now, I can technically factor this by grouping. So I can factor out an x squared and a 4, and I'd get x minus 3. But you might not see that, and it might not always work. So here's the next process you would do. So 1's out, or positive 1's out, and then 2's out. So I'm just going to go down the list. I'm going to try 3 using this same thing. There's going to be 1, negative 3, 4, negative 12. So if 3 would have worked here, then I would still got 0. I could have tried 2 as well. The goal is if it's a 0 of the original, it's going to be a 0 of any factor that comes out of it. So let's try 3. So this gives me 0, 0, 4, 12. Perfect. Love doing that on the first try. So then this right here would then give me x squared, no x's, plus 4. So right now I have 2 and 3 that are answers. Now I just got to set this to equal to 0 and solve. So I get x squared equals negative 4. And then when I take the square root, I get x equals plus or minus, because we can't forget the plus or minus, 2i. Because there's the next square root of the negative is an I, and the square root of 4 is a 2. So my answers here, we'll do my imaginary numbers first. So plus or minus 2i, and then 2 and 3. All right. So let's do some more. Let's look at number 4. So this is h of x equals x cubed minus 3x squared plus 9x plus 13. So my potential zeros, my factors of 13 is 1 and 13 and 1. Oh, you gotta love questions like this. So plus or minus 1 and 13. Only got 4 options, right? So we just gotta randomly choose one of them. So I'm gonna try 1. That's the routine I've been using. So x cubed is 1, x squared is negative 3, x is 9, and my constant is 13. So 1 times 1 is 1, negative 2 plus 1 is negative 2, 1 times negative 2 is negative 2, 9 plus negative 2 is 7, 1 times 7 is 7, 13 plus 7 is 20. Unfortunately, 1 did not work. I don't think 13 is going to work either, just kind of looking at it because it's pretty big. I'm just going to go to negative 1 next and see what that does. If not, I'll try 13. If this got this big, I think 13 would be just as big. 1, negative 3, 9, 13. So negative 1 times 1 is negative 1, negative 4, 4. There we go, 13, negative 13. So that gives me 0. So that does work. Again, 13 I can see is this going to get bigger and bigger if this got this size. So this would be x squared minus 4x plus 13. Two things that multiply 13 and add a negative 4, there is nothing. So I'm going to go to the quadratic formula, which remember is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So it's going to be negative 4 plus or minus negative 4 squared minus 4 times 1 times 13 divided by 2 times 1. So simplify that. That gives me 4 plus or minus 16. 4 times 13, that's 40, 12, 52. Over 2. 16 minus 52. 40. Nope. 36. That looks like a 36. Negative. Because that would give you 46, 52. Yeah. And then that right there would then be 4 plus or minus 6i over 2, which is simplified is 2 plus or minus 3i. So there's your actual answers then. We get 2 plus or minus 3i and negative 1. All right, so let's look at, so again, I want to make sure you have plenty of examples to look at. So q of x is equal to x cubed minus 10x squared plus 23x minus 14. So again, my potential zeros is factors of 14. So that's 1, 2, 3, 4, 5, 6, 7. And then that would be 14. And then what? So this is plus or minus 1, 2, 7, 14. And then so now I just go through the list and see what I find. So I'm going to try 1. X cubed is 1. X squared is negative 10. My x is 23, and my constant's negative 14. That's an arrow, man. That looks like a 2. 1, negative 9, negative 9, 14. 14 is 0. That worked. So then that becomes x squared minus 9x plus 14. Two things that multiply 14 but add up to negative 9 would be 7, 2, negative, and negative. And so therefore that gives you x equals 7 and x equals 2. So your actual zeros would be 1, 2, and 7. All right. Let's look at another one. Let's look at number 6. 6 is r of x equals x to the 4th plus x cubed plus 23x squared plus 25x minus 50. Again, potential zeros are all your factors of 50. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. And so then that would be 2 and 25 and 1 and 50 all over 1. So this gives you plus or minus 1, 2, 5, 10, 25, and 50. So then I come over here and let's see, work some out. Just trust my number 1. And then x to the fourth would be 1, x cubed would be 1, x squared would be 23, x would be 25, and my constant's negative 50. I feel like this will work. If not, negative 1 definitely will work. Gotta love that. All right, so then this gives me x cubed plus 2x squared plus 25x plus 50. Let's see, let's try negative 1 then. We'll leave that there. So that's going to be x cubed is 1, x squared is 2, x is 25, and my constant's 50. Circle that answer so I don't lose it. 1, negative 1, 1, negative 1, 24, negative 24. Yep. That's going to add up. So let's try 2. Again, using these values here. So x cubed is 1, x squared is 2, x is 25, and my constant's 50. 2 times 1 is 2, 4, 8, 33, 66. Ain't going to work. Maybe negative 2. So 1, 2, 25, 50. Negative 2, 0, 0, 25, negative 50. Bam, there it is right there. So then this would give me x squared plus 25 equals 0. So then x squared equals negative 25. Take the square root of both. So that gives me x equals plus or minus 5i. So then my actual zeros are plus or minus 5i, negative 2, and 1. All right, I'm going to skip to number 10. I saw one like this on your homework. K of x equals x to the fourth minus 10x squared plus 24. Same process. Find your potential P's and Q's, even if you're missing some terms. 1, 2, 3, 4, 5, 6. Right, because 4 times 6, 12, 24, yeah. So then 8, 12, and 24 all over 1. So this gives you plus or minus 1, 2, 3, 4, 5, 6, 8, 12, and 24. All right, I'm actually going to, just seeing how this kind of doubles, I'm going to kind of go by 2 and see what happens there. So this is x to the fourth is 1, x cubed is 0, x squared is negative 10, x is 0, and my constant's 24. So you have the placeholders there. That's going to be 2, 2, 4, negative 6, negative 12, negative 24. That's what I thought was about to happen. All right, so therefore this is now x cubed plus 2x squared minus 6x minus 12. Again, if you didn't realize that this can be factored using the grouping method, I'm going to try negative 2 and see how I'll go with that one. So that'd be 1, 2, negative 6, and negative 12, because that'd be my x cubed, x squared, x, and constant. Negative 2, 0, 0, negative 6, 12, 0. Perfect. So that gives me x squared minus 6 equals 0. So that gives me x squared equals 6. So square root, x equals plus or minus I square roots of 6. They might put the I right there. So I like to put the I in front. So this is plus or minus I square root of 6. And then you got 2 and negative 2. So plus or minus 2 in that case too. All right, so I want to show you one that had some missing terms. All right, so let's move into a different section, which it says use the rational zero theorem or your answers to the preceding problems to solve the following equations, which is the same process as what we're doing, but we don't technically have to find the potential zeros, but you almost do because you need that to start off the process. So let's look at 13. I don't think we've done one like this yet. Yeah. we have to work it out. So 13 is x to the fourth plus x minus 2 equals negative 2x to the fourth plus x plus 1. So what we have to do first is get this set equal to 0. So I'm going to add 2x to the fourth on both sides, lining up my like terms. Subtract my x, subtract my x, subtract my 1, subtract my 1. Again, it doesn't matter which side you decide to go on. This gives me 3x to the fourth. That actually goes away. Minus 3. I'm going to solve this like normal. So I'm going to add 3 on both sides. This gives me 3x to the fourth equals 3. Divide by 3. So this gives me x to the fourth equals 1. And then I'm going to take the fourth root of this. All right, so this is where it gets interesting. When you're dealing with the fourth root, because there's going to be 4 answers. So this is not just plus or minus. This will give you plus or minus 1, because both of those would give you 1. But because it's squared, or to the fourth, there's 2 more answers. So here's my recommendation. It's not so easily seen. I'm going to use those, knowing that those are zeros. I'm going to simplify. Where is it? Up to this point. So x to the fourth would be 3. X cubed is 0. X squared is 0. X is 0. And my constant's negative 3. Oh, no, that's where I messed up. 1 times 3 is 3. 3, 3, 3. Because 1 times 3 is 3, 0 plus 3 is 3, 1 times 3 is 3, 0 times 3 is 3. Bunch of 3s, which so happens to work out. So this is 3x cubed plus 3x squared plus 3x plus 3. I'm going to use that in the fact that negative 1 will also be an answer. So that'd be 3, 3, 3, and 3. So that's negative 3, 0, 0, 3, negative 3, 0. So both of them will have to work. So this is 3x squared plus 3. So now I can solve this one. So 3x squared equals negative 3. And then x squared equals negative 1. And here's the other 2 answers. That's why we couldn't easily see them either. It'll be plus or minus I. It's imaginary. So in this case, your answers are plus or minus I and plus or minus 1. All right, so because it's a fourth power, we could see this, but we couldn't see the other 2. And the reason we couldn't see the other 2 because they happen to be imaginary. But knowing that these were zeros, I was able to plug them in to get it down a quadratic to see what is those imaginary part of the answers. All right, so let's look at number 14. All right, 14 is x to the fourth plus 10 equals 10x squared minus 14. So I'm going to get everything to one side. So I'm going to subtract 10x squared. There's no like term, so I'm going to put it in the middle here. Plus 14, plus 14. That goes away, that goes away. So I get x to the fourth minus 10x squared plus 24. Do keep it in standard form. See, this is kind of like a quadratic. 2 things that multiply to, yes, we can do this. So in our factoring techniques that we learn, this is x squared and x squared. And then this right here, what multiplies to 24 and adds to 10 would be 2 and 12, negative positive. Never mind. So we get 2 and 12, 3 and 8. 4 and 6 would have worked though. 4 and 6. So yeah, that gives you a positive 24 and negative 10. So then I get x squared minus 4 equals 0 and x squared minus 6 equals 0. So this is x squared equals 4, which is square root of that. It's going to be plus or minus 2. And then x squared equals 6. Square root of that is going to be x equals plus or minus the square root of 6. So notice if we would have done the potential zeros, we would have got these, but these would not have been ones that shown up. So that's why they're potential, but that all of them are listed. So this is plus or minus 2 and plus or minus the square root of 6. Let's look at one more. Let's look at 15. 15 is x cubed minus 3x squared plus 9x plus 13 equals 0. It's already said equal to 0, so I can look at this and go, can I factor anything? And there's nothing I can do here, so I am going to have to go through the process. Actually, didn't we do one like this already? We did. This is actually just like number 4. So I'm not going to even finish this off because we already did it. I was going to say these numbers look the same, just like 4. So again, yeah, because that's what we dealt with. So it's x cubed minus 3x squared plus 9x plus 13. Yeah. So this is just like 4. So this gives you another example of just looking at it. I realized they repeated. All right. So the last kind of questions you're going to get is using the intermediate volume theorem. So let's skip to number 57 now. And so you're given f of x equals 5x cubed minus 4x squared minus 31x minus 6. And then you're given -3 and -1. The question is, use the intermediate volume theorem to show that each of the following polynomials has a real zero between the indicated values. A real zero meaning it crosses the x-axis, which means it had to equal 0. So all you have to do on these type of problems is literally just plug it in. So this is going to be 5 times -3. Actually, we can use the synthetic division process, the remainder theorem. And -3, since that's what's being plugged in, can be 5, -4, -31, and my constant's -6. So this gives me -15, -19. Really hoping this would have been easier. 19, that's almost 60. Take away 3, what's that, 57? And then 57 minus that would give me 26. 57, simple math. And then, hold on. I pull up a calculator. All right, so this is going to be 26 times 3. So that's -78 plus 6. So that gave me -84. So -84 is what f of -3 would be. And then do the same thing with -1. The goal is I'm just looking for a positive. If I get a positive, then the answer to this question is yes. Oh, 31 minus 9 is -22. All right, I think I've done enough math for the day. Let's see. So 31 minus 9, 22. And then that's 22. And then that would be 16. Then -6. Yep. Okay, so then 16 would be what f of -1 is. And since you got a negative and a positive, the answer here is yes. The intermediate volume theorem does work. All right, let's do one more so you can see it. So I'm going to do number 58. 58 says f of x equals x to the 4th minus 9x squared minus 14 for 1 and 4. Again, to figure out f of 1, I'm going to use synthetic division. This seems to be faster than actually plugging it all in. And that would give you what, -22. So again, that is what f of 1 would be. I'm going to try 4. All right, 28, what's that, 5,612? 28 times 412. And then that would just be 2,798. That would be again yes, because one was negative and one was positive. All right, and that's all you have to do to apply the intermediate value theorem. All right, so that's pretty much all that I have for this video. As always, if you have questions, continue emailing me. Other than that, I'll see you in the next video. Bye for now.